Okay, in this video we're going to take a look at how to balance chemical equations. Now before we start into the process, I need to mention something here. These two equations you see written, these are already contain correct chemical formulas, and that's a very important part of this. You have to have a chemical formula that represents the compound that you want. Okay, it just can't be random numbers. For example, this right here, that 3 and this 8, that's what makes this what we call propane. C3H8. Now I can't just go randomly changing that sort of thing. I can't just go change the C to a 4 and the H to a 10 like I have down here, because that completely changes what the compound is. So first rule of thumb for balancing equations is don't change the subscripts, the little numbers. Those are what makes that compound unique. And so if we change those, we completely change what that substance is. Okay, so I'm going to erase those little arrows and we'll get into the actual process of balancing these things. Now, balancing chemical equations does not have to be a complicated affair. Okay, what we're going to start with is we're going to look at this arrow, kind of like a dotted line, and we're going to say however many atoms total of each element we have on the left, we have to have the same amount on the right. Okay, we can't have certain atoms disappearing in a reaction, and we can't have atoms just showing up out of nowhere. Okay, the conservation of matter says that whatever we start with, we have to finish with. It's just arranged differently. So what I'm going to do in this one is I'm going to first notice in this equation that oxygen shows up in a lot of places. So I'm not going to start with that element. I'm going to focus on something that's going to be a little easier. I'll worry about oxygen at the end. Okay, so I'm going to start maybe with carbon. Okay, I can see there's 3 carbons on the left and only 1 carbon on the right. So if I put a 3 out here, now I've got 3 carbons on the left and 3 carbons on the right. But I can't just have 3 carbons on the right with that big 3 there. That means I also have the 3 also applies to the oxygen. Okay? And since I have 2 oxygens in each molecule of carbon dioxide, I really have 6 oxygens on this side. Okay? Now I'm not going to worry about that just yet. I dealt with the carbons. I know the oxygens aren't balanced. Let's get to that later on. Okay, I'm going to go back over here to hydrogen. Okay, and when I look right here, I've got 8 hydrogens on the left. On this side, I've only got 2. So I'm going to need to put a 4 right here. Now I've got a total of 8 hydrogens. And now the last thing I'm going to do, I still have oxygen to worry about, so I'm going to see what I've got there. I'm going to take a look at this entire side over here and see what I've got. Okay. It looks like I said before, it looks like I've got 6 oxygens on this side, plus another 4 oxygens over here, so I have a total of 10 oxygens. Okay. Now on the other side, I've already got 2 of them there. So if I want to have 10 oxygen on this side, I'm going to need to put a 5 out there. And now we say that this chemical equation right here is balanced. Okay, I basically just remind you of this. There is really a 1 in front of that propane, so 1 propane molecule reacts with 5 oxygen molecules to give me 3 carbon dioxides and 4 waters. Okay, now let's look at another example just below this. It's basically the same thing, but I'm going to show you a little trick. Okay. If I approach this the same way, I look at this one and go, oh, 4 carbons on this side, so I'm going to need a 4 right there. That seems pretty normal. And I look over here and say, oh, there's 10 hydrogens. Well, let me put a 5 right there. Now I got 10 hydrogens. Everything's moving just fine. But when I get to the oxygen, something doesn't work out. Okay? As I add these up, I've got 8 oxygens over here, plus 5 oxygens right here. Okay, I know it looks like 80 plus 50, but remember this is oxygen that I'm talking about. Okay, that gives me a total of 13. Now how in the world am I going to get 13 out of this molecule when they have to be diatomic? Well, I could put a 6.5 here. And we don't usually write balanced equations with decimals. We like to have whole number ratios. So the quick way around this now is to remember I have a 1 in front, 6.5, 4, and 5. I'm going to take this and double everything. So I'm going to get rid of this. Oops. Let's see if I can change colors here. Get rid of that, and I'm going to double each one of these numbers, and I'll have it balanced. So if I take 1 and double it, I would get a 2. So I have 2 butanes. 6.5 doubled is 13. 4 doubled is 8. 5 doubled is 10. And so what I wanted to show you in this was, if you ever have to put a 0.5 in there to balance it, well, go ahead and put the 0.5 right here. Go ahead and put a 0.5 there, and then just double every number, and all of a sudden you have the smallest whole number ratios you could have.